Let's go to LeetCode 2742, painting the words. For this question, it gives us the two zero index array, cost and time. And of the size n represent the costs and time taken to paint the n different words respectively. So we'll say int n equals cost dot length, right? So there are two painters available. A paid painter that paints ice wall in time I, unit of time, and take cost I, unit of money. So this cost and time are the paid painter's cost and time. And a free painter that paint any wall in 1 unit of time and the cost of 0. That means if we select, for example, select some of the paid painter, right? Then we use this kind of cost in this kind of time. And we can also select free painter. For example, if the first wall we select a free painter, we are using cost 0, and the time we are using is 1, right? Because it says that it's 1. And if the first we use the free painter, we cost is 0, and the time is also 1, right? But it says that the free painter can only be used if the paid painter is already occupied. So that means for this question, it means the paid only the paid painter the time. For example, we select those kind of time, right? So if we select, for example, the index 1 and 2, so the paid painter will have use this kind of time 2 and 3, right? So that means the paid painter use of 5 units of time. And so that means the time slot for our free painter, right? Every worker, for example, it's using every work is using 1 unit of time, right? So that means our paid painter the time should greater equal to the free painter total time. That means the paid painter is occupied, right? So for this kind of scenario, for example, what we select, we can select for example, select this kind of the number 2, right? Number 2 word to be the paid painter. And for this one, for example, we have we select number 2. The cost is 3 and time occupied is 3, right? And in that case, we can set the rest to be free. And every unit of that word is just 1 unit of time, right? 1 unit of time. So you will say this is occupied because what that means that is the total time of the paid painter should be the total time of the free painter, right? So for every words for free painter, you take one unit of time, but for every word which use the paid painter, it takes the times I unit of time. So the sum of the time I should be sum of the how many? Yeah, so that means time I sum of should be greater than n minus I, right? That means so it's trying to ask us the minimum cost. So for this question, for every word, we'll say we can select a paid painter or a free painter, right? So we can say select a paid painter. This is like a backpack problem. We have a paid painter select or not, right? So we'll say for every the constraint here is that the sum of the paid painters. So that, for example, I select those kind of index I, right? Some of the selected well greater equal than, right? Then those kind of free painters time. The free painter is a minus sum of the selected number, right? Select number. So that is a counts, right? That counts selected. So if this I is selected, right? So that is one, right? If I, how can we write this kind of formula? I selected, that is one, right? Selected is one. Otherwise zero. So this will be the free painter the time. This will be the paid painter the time, right? So if we change this one to another formula, it will be sum of the selected paid painter, right? Paid painter which we selected plus one, its time should be greater or equal to this n, right? So we are trying to have n words, right? N words, and we trying to for each one we can select as the paid painter, or we do not select as paid painter, and but we should have the condition, the time used for the selected painter, the sum should be greater or equal to n, right? So this is the backpack problem. So what we are going to do is that we're going to have int dp. And also the thing is that we are trying to find a minimal cost for this kind of condition. So dp equals new int. We'll have n plus one, right? Because there are n words, right? And we also have this kind of object in the back problem. We can call this as a weight, right? So we'll see this kind of weight. We are trying to see the weight to be n. What's the minimal cost, right? So we are trying to see so the thing is that we are going to have a backpack bag which has the capacity to be n, right? We should at least cover it. We should have cover the n, find the least cost to the total cost, right? So we'll have dp I j, which will mean for the first previous ice item, we occupy J capacity, right? The minimal cost J capacity. So now the capacity, the things that we are trying to do that this is, for example, we have capacity capacity I, right? So this one is actually the time time I plus 1, right? So this is this is like the object capacity, right? So it is 10 plus 1. So this is we are going to have a dpij is for the previous ice item occupied J capacity and the dpij is the minimum cost, right? So each item we select, for example, each the paid worker painter, it will use this kind of capacity. So what we are going to do is that we are going to have because we are trying to find the minimum one, right? So we are going to initialize this one as some kind of max value private final static int inf equals integer dot max value. We're going to do this, right? So we are going to do is that for every DP arrays fill the INF, and we are going to have the DP 0, 0, right? So that means for no item, right? No item selected, and also we didn't use any capacity or on the backpack, so that will be 0, right? So what we're going to do is that we are going to for loop for int I equals 1, I smaller I smaller than equal to n, right? I plus plus, and we are going to have for int j. This is a weight or capacity equals 0. J smaller equal to n, j plus plus, right? So we are trying to find its minimal, right? So we'll have dp I j equals for this ice item, right? Or if we do not select it, right? So the minimal cost, that is I minus 1 j, right? And if we select it, then we'll have dp I minus 1 j minus minus this capacity is times and so we need this capacity at least to be times I minus 1 plus 1, right? Because every item it is times I plus 1, right? But we have one more index shift. And this can be smaller than 0, right? So I have a max per max dot 0 and this value. And we are going to max this, right? And for this kind of value, we'll select current cost, right? So that will be cost I minus 1, right? So we're trying to find the minimal cost for this kind of two scenario, right? In the end, what we're going to do return is return dp n, right? So dp n, what's the problem? So I minus 1 max g 0. This will be this. Actually, this bracket is here, right? Because this is the selector, right? And this is for current item, we do not select paid painter, right? So this is the two-dimensional array for the DP, right? So if we look at this kind of DP iterations, every DPIJ, it comes from the up and also these two directions, right? For the I loop and for the J, so every DPIJ is coming from here and here, right? So we know for the 1-0 backpack problem, the two-dimensional DP can be converted to one-dimensional DP, right? So what are we going to do is that we just use a one dimension here. Let's comment this. So we'll have int dp equals new int n plus 1, right? And we just have arrays fill dp inf. So we'll say dp 0 equals 0, right? So this is corresponding to this dp 0, the line 12. So because every dp ij is coming from its up and left up, right? These two directions. So the for I iteration, we still iterate like this, right? But now we should have I from 0, right? Because we want to, but for j, we should do a reverse direction because it's coming from here. We do not want the new value to overwrite the right value we are trying to use. So what we do is that So we are going to do is that for int I equals 0, I smaller equal to n, I plus plus, and we are going to do is that for int j equals n, j greater than 0. J minus minus, right? So I have dp j equals mass dot mean dpj and dp mass dot max j minus time should be have this, right? Time I minus 1 plus 1, right? This is every item's weight, and should be greater than 0, right? And add cost I minus 1, right? And in the end, just return dp and dpj dp mass max j minus time should be this, and in the end, yeah. Let me correct something I said wrong, right? So, and this one we still iterate n times. We can either use I equals 0 to n, right? A minus 1. Or we just be the same as what we did in the previously from 1 to n, right? How it's a shift one index, and if this kind of dp shift one index, our time should be I minus 1. This cost should be I minus 1, right? And in the end, we return dp n. This n is from the j, that is the width, right? Not related to the I dimension. So this way we converted the 2-dimensional dp to 1-dimensional. The time complexity will be O(n) square, and the space is O(n). And the previous one is space is the first solution is also O(n) square.